Hey guys, how's it going? Today we're going to look at some different shuffling algorithms. Shuffling is a pretty simple concept actually, but it's important to know how to do it and how to do it efficiently. So I'm going to switch to tutorial scene. All right, so this is pretty simple. We have a list of numbers given to us: 1, 2, 3, 4, 5, 6, 7, 8, 9. And we're going to look at two different methods of shuffling. One I called slow shuffle because this is slower than the other algorithm here, which is in-place shuffle. So one thing that comes to mind is, generating a random number and inserting it into the array we have. But the thing is, we need to be aware of not duplicating the numbers, because essentially we only have a certain number of elements that exist a certain number of times in our list. So if we were to just generate a random number for each index, we might be duplicating the numbers we have. So we don't want to do that. So another way to do this would be a good explanation is if we put all these numbers in a hat, and we pick numbers from the hat and randomly pick them from the hat and put them in a list. That would be a pretty shuffled random algorithm. So to do that, we're going to start by checking the count. Basically, if our count is less than 2, we can just return our array because we don't need to shuffle that one. So this algorithm, we're going to create a copy array that's mutable. So basically, while our count is greater than 0, we're going to count down. We're going to create a random number. It's going to be from 0 to count. Then we'll have a result array. So think of this like our hat, and then we're picking from the hat and insert it into the result array. So we're going to append what's in the copy array at the random number index, and then we're going to remove that item from the copy array, not to pick it again. We're going to decrement our count, and we return our result array. And I think that's it. So the issue with this algorithm is that removing an item from the array is a bit costly in terms of speed. So even though it works, it's not the most efficient way. So as you see, our array is shuffled here, and at the beginning it starts with, correct sorted order. So what's one way to do this more efficiently and better? If you think about actually swapping items from the last index of the array as we go through, will have the same randomizing effect. So our beginning will be the same as in-place shuffle. Also, we don't need to create a result array, or because we're going to be swapping items this time. So while our count is greater than 0, we're going to decrement count by 1, and we're going to create a random number again. So count, and this time, instead of removing the item, we're just going to swap item, the last item with the random number we picked. Then we return our array. And I believe this is it. So let's run this one. Something went wrong. We need to do count minus 1 for this one. And yeah, there we go. So the first shuffling resulted with this. The second one resulted with this. So here's something a little better, perhaps. So these algorithms are for shuffling integer arrays, but can we shuffle any array given to us, or an array of any type? And the answer is yes, we can. We can use generics for that. So I'll call this generic shuffle, and we're going to pass an argument t into our array. We're referencing the array, so we'll have to use a in-out again. The beginning will be the same. Actually, most of the algorithms are just the same, because all we're doing is we're dealing with the indices and whatnot. So yeah, all we had to change was inputting a generic item t, and that's it. And that's about it. Thank you for watching, guys. Have a good day.